Good day, everyone. I'm Mariano, and our today's topic is about two-way analysis of variance. Since it was already discussed by the previous reporter on what is two-way ANOVA, let's proceed to the first example. For example 1, gasoline consumption. A researcher wishes to see whether the type of gasoline used and the type of automobile driven have any effect on gasoline consumption. Two types of gasoline, regular and high octane, will be used, and two types of automobiles, two-wheel and four-wheel drive, will be used in each group. There will be 2 automobiles in each group for a total of 8 automobiles used. Here we are going to test the effects of two independent variables or factors, which are the type of gasoline used and type of automobile driven, on one dependent variable, which is gasoline consumption. Using a two-way analysis of variance, the researcher will perform the following steps. Step 1, state the hypothesis. Step 2, find the critical value for each f-test using alpha 0.05. Step 3, complete the summary table to get the test value. Step 4, make the decision. And Step 5, summarize the results. Again, in two-way ANOVA, it involves two independent variables, also called factors. And based from the table shown, we have two factors, which are the type of gasoline and the type of automobile. Under the type of gasoline used, we have regular and high octane, and for the type of automobile driven, we have two-wheel drive and four-wheel drive. It is also indicated in the table the data in miles per gallon. So for regular and two-wheel drive, we have 26.7 and 25.2. For regular and four-wheel drive, you have 28.6 and 29.3. For high octane and two-wheel drive, you have 32.3 and 32.8. And for high octane and four-wheel drive, we have 26.1 and 24.2. For Table 1, we have the ANOVA summary table. Since na-discuss na din ito ng previous reporter, so i-recall na lang natin. For sources, we have gasoline A as our first factor, gasoline B as our second factor, their interaction A multiplied by B within error. For sum of squares, we need to find the sum of squares for factor A, for factor B for interactions, sum of square for error team or within group. For our degrees of freedom of first factor, we have a formula of A minus 1. Second factor, we have B minus 1. Both factors, we have quantity A minus 1 multiplied by quantity B minus 1. Within error, we have AB multiplied by quantity N minus 1. For mean squares, we need to find the mean squares for factor A, for factor B, for interaction, for error term, or within group. Lastly, for F value, we need to find the F value for factor A, for factor B, and for interaction of both factors. Step 1, state the hypothesis. For the gasoline type, null hypothesis states that there is no difference between the means of gasoline consumption for two types of gasoline. Alternative hypothesis states that there is a difference between the means of gasoline consumption for two types of gasoline. For the types of automobile driven, null hypothesis states that there is no difference between the means of gasoline consumption for two-wheel drive and four-wheel drive automobiles. Alternative hypothesis states that there is a difference between the means of gasoline consumption for two-wheel drive and four-wheel drive automobiles. And for the interaction of two independent variables, null hypothesis states that there is no interaction between type of gasoline use and type of automobile a person drives on gasoline consumption. Alternative hypothesis states that there is an interaction effect between the type of gasoline use and type of automobile a person drives on gasoline consumption. Step 2, find the critical value for each f-test using alpha 0.05. In this case, each independent variable or factor has two levels. So, gumamit tayo ng 2x2 ANOVA table. Factor A represents as the gasoline type. It has two levels, regular and high octane. Therefore, A is equal to 2. Factor B represents as the automobile type. It also has two levels. Therefore, B is equal to 2. The degrees of freedom for each factor are as follows. For factor A, the degrees of freedom numerator is equal to A minus 1. Substitute the value of A, so 2 minus 1 is equal to 1. For factor B, the degrees of freedom numerator is equal to B minus 1. Substitute the value of B, so 2 minus 1 is equal to 1. For the interaction of both factors, the degrees of freedom numerator is equal to quantity A minus 1 multiplied by quantity B minus 1. Substitute the value of A and B, so 2 minus 1 multiplied by 2 minus 1 is equal to 1. For within error, degrees of freedom denominator is equal to AB multiplied by quantity N minus 1. Substitute the value of A and B and also N, where N is the number of data values in each group. So 2 times 2 is 4, multiplied by 2 minus 1 is equal to 4. So our degrees of freedom numerator is 1 and degrees of freedom denominator is 4. Take note lang na if there are different levels of the factors, the critical values will not all be the same. For example, if factor A has 3 levels and factor B has 4 levels, like a 3/4 ANOVA, and if there are 2 subjects in each group, then the degrees of freedom for numerator and denominator of each factor will be different. The critical value for the F value of factor A is found by using alpha 0.05, degrees of freedom numerator is equal to 1, and degrees of freedom denominator is equal to 4. In this case, the critical value for the first factor is 7.71, same with the second factor and the interaction of both factors. So 7.71 din ang kanilang critical value. Okay, so yan pinakita lang dyan kung paano nakuha yung critical value na 7.71. Step 3, complete the ANOVA summary table to get the test values. The sum of squares are computed first. So para makuha natin ang sum of squares, kunin muna natin yung mean of the data values each group and also the total average and the grand mean. For regular, 2-wheel drive and 4-wheel drive, we have a total average of 27.45. For high octane, 2-wheel drive and 4-wheel drive, you have a total average of 28.85. For 2-wheel drive using regular and high octane, we have a total average of 29.25. And for 4-wheel drive using regular and high octane, we have a total average of 27.05. And our grand mean is 28.15. Let us compute first the sum of squares for factor A. We have a formula, the summation of the number of data for factor A multiplied by the total mean or average for factor A minus the total grand mean squared. We have 4 multiplied by 27.45 minus 28.15 squared plus 4 multiplied by 28.85 minus 28.15 squared. So the sum of squares for factor A is 3.92. Next, the sum of squares for factor B, the summation of the number of data for factor B multiplied by the total mean or average for factor B minus the total grand mean squared. We have 4 multiplied by 29.25 minus 28.15 squared plus 4 multiplied by 27.05 minus 28.15 squared. So the sum of squares for factor B is 9.68. And for the sum of squares within error, our formula is the summation of x or the data values in each group minus the mean value in each group squared. For regular, 2-wheel and 4-wheel drive, 26.7 minus 25.95 squared is equal to 0.5625. 25.2 minus 25.95 squared is equal to 0.5625. 28.6 minus 28.95 squared is equal to 0.1225. And 29.3 minus 28.95 squared is equal to 0.1225. The total is 1.37. For high octane, 2-wheel drive and 4-wheel drive, 32.3 minus 32.55 squared is equal to 0.0625. 32.8 minus 32.55 squared is equal to 0.0625. 26.1 minus 25.15 squared is equal to 0.9025. And 24.2 minus 25.15 squared is equal to 0.9025. The total is 1.93. So just add 1.37 to 1.93 and our sum of square within error is 3.3. Next is the sum of square for total. The formula is the summation of x or the data values in each group minus the total grand mean squared. So we will just minus the data values in each group, which are 26.7, 25.2, 28.6, 29.3, 32.3, 32.8, 26.1, and 24.2 from the grand mean, which is 28.15 and squared lang natin. So the total sum of squares is 70.98. Now, it's easy for us to find the sum of squares for interaction. The formula is total sum of squares minus the sum of squares for factor A minus the sum of squares for factor B and minus the sum of squares within error. So, nakuha natin is 54.08 as our sum of squares for interaction. The mean squares are computed next. Mean squares for factor A is equal to sum of squares for factor A over A minus 1 is equal to 3.920 divided by 1 is equal to 3.920. Mean squares for factor B is equal to sum of squares for factor B over B minus 1 is equal to 9.680 divided by 1 is equal to 9.680. Mean square for interaction is equal to sum of squares for interaction of both factors over the quantity of A minus 1 multiplied by the quantity B minus 1 is equal to 54.080 divided by 1 is equal to 54.080. Mean square within error is equal to sum of squares within error divided by AB quantity n minus 1 is equal to 3.300 divided by 4 is equal to 0.825. So, in short, kung mapapansin nyo, to get the mean squares, we will just divide sum of squares to the degrees of freedom. The f values are computed last. To get the f values for factor A, we will just divide the mean square for factor A to the mean square within error, so we get 4752, and our degrees of freedom numerator is 1 and degrees of freedom denominator is 4. Same with the f values for factor B, we will divide the mean square for factor B to the mean square within error, so we get 11.733. And our degrees of freedom numerator is 1 and degrees of freedom denominator is 4. Lastly, for the f values for the interaction of both factors, we will divide the mean square for interaction to the mean square within error, so we get 65.552, and our degrees of freedom numerator is 1 and degrees of freedom denominator is 4. So we have now the completed ANOVA table. We find the sum of squares, degrees of freedom, mean squares, and f values. Since it's complete, let's proceed to the next step. Step 4, make the decision. For gasoline A, the critical value is 7.71 and the f value is 4.75. Since f squared does not fall in critical region, therefore we will not reject the null hypothesis. For automobile B, the critical value is 7.71 and the f value is 11.73. Since f squared falls in critical region, therefore we will reject the null hypothesis. Lastly, for the interaction of both factors, the critical value is 7.71 and the f value is 65.55. Since f squared falls in critical region, therefore we will reject the null hypothesis. In general, since the f value for factor B is 11.73 and f value for interaction is 65.55 are greater than the critical value 7.71, the null hypothesis concerning the type of automobile driven and the interaction effect should be rejected. Step 5. Summarize the results. So we found out that there is a difference between the means of gasoline consumption for the two types of gasoline. There is a difference between the means of gasoline consumption for the two-wheel drive and four-wheel drive automobiles, and there is an interaction effect between type of gasoline use and type of automobile a person drives on gasoline consumption. And since the null hypothesis for the interaction effect was rejected, it can be concluded that the combination of type of gasoline and type of automobile does affect the gasoline consumption. So in the preceding analysis, the effect of the type of gasoline use and the effect of the type of automobile driven are called the main effects. If there is no significant interaction effect, the main effects can be interpreted independently. However, if there is a significant interaction effect, the main effects must be interpreted cautiously. Para ma-interpret natin yung mga resulta ng two-way ANOVA, since meron itong interaction effect, gagawa tayo ng graph and ipa-plot natin yung means of each group. So, to find the means for each group, add lang natin yung data values in each cell and divide natin kay n, which is 2. For regular and two-wheel drive, you have a mean of 25.95. Regular and four-wheel drive, you have a mean of 28.95. For high-octane and two-wheel drive, you have a mean of 32.55. And high-octane and four-wheel drive, you have a mean of 25.15. The graph of the means for each of the variables is shown. So, kung makikita natin, the lines cross each other. When such an interaction occurs and the interaction is significant, the interaction is said to be disordinal interaction. And when there is a disordinal interaction, you should not interpret the main effects without considering the interaction effect. So, yung interaction natin sa example ng gasoline consumption is called disordinal interaction. So, hindi lang disordinal interaction ang ma-encounter sa ANOVA. The other type of interaction that can occur is an ordinal interaction. The next figure shows a graph of means in which an ordinal interaction occurs between two variables. Kung mapapansin nyo, the lines do not cross each other and hindi rin sila parallel. If the test value for the interaction is significant and the lines do not cross each other, then the interaction is said to be an ordinal interaction and the main effects can be interpreted independently on each other. So sa last, when there is no significant interaction effect, the lines in the graph will be parallel or approximately parallel. When this situation occurs, the main effects can be interpreted independently of each other because there is no significant interaction. So, ito yung nakuha natin in using Excel, and as you can see, nag-match naman ito sa sinolve natin manually. Hindi ko na masyadong i-explain to since i-discuss na ito ng next reporter. So, that's all po. Thanks for watching.